Welcome back to another edition of Higher Education Today. I'm your host, Stephen Roy Goodman. I'm here in Alfred University in Alfred, New York, where we're going to be speaking about space materials. And I have three guests with me today. Holly Shulman, who's the director of the Alfred University Space Materials Institute. Matt Creedon, who is the research and development manager at Washington Mills. And Roque Santiago, who's a materials science and engineering student at Alfred. Welcome to all of you.
Thank you.
Thanks for having us.
Well, thanks for coming. Holly, maybe if we could start with you. Why does a university have a Space Materials Institute?
Well, we launched the Space Materials Institute in November, realizing there's a need for educating our engineers and other students for the workforce of the future, where they will have positions doing things that we right now are just starting to invent. So we want them to be educated in that way and also have hands-on experience with developing materials and using them and be able to also integrate with teams. So it's very important not just to work with professors and their other peers, but also to interface with industry and understand the pace and the needs of industries that they will be going into.
When speaking of the industries, what would you say in terms of what's your interaction in terms of the space materials, and why are you involved in this kind of collaboration with the university?
Well, a few years ago, Holly had a project going with NASA, still does. She told NASA that I might be able to help her through the work I do at Washington Mills, where we make a lot of powder and other abrasive materials. And so we got involved in making a lunar regolith simulant, so basically a fake moon dust, so that they can use it, NASA can use it to practice doing the things that they are going to have to do once we go to the moon.
And why would you, this might sound like a crazy question, but why would you want fake moon dust?
Well, just like the dirt we have here on Earth that's used to make all of our construction materials, all the minerals and raw materials that we use to build our buildings and make our metals and all that, you need to learn how to do that on the moon. Unfortunately, it's hard to get soil from the moon right now. So we create, and there's a few different ones. We create these different simulants, they're called, to work with and practice, so we know what we're doing when we get there.
Well, that's really interesting. And Roque, you're a student here. I assume you're studying some of these issues.
Yes, yeah. I'm a material science and physics student here, and I don't necessarily have a class that directly talks about space materials, but just through my classes, I'm exposed to polymer science, metallurgy, ceramic science, and I build kind of a foundational tool set that then through work with Holly and work in the Space Materials Institute, I go and apply those tools. And although space materials aren't always just like normal materials, the foundational concepts and the way they behave is very similar to things I'm learning in class. So I can take those tools right from class and bring them into a working environment and develop some processes for off the Earth.
Well, maybe I could ask all of you this question. So as someone, I've never been to the moon. I assume none of us have been to the moon here, and the average person watching this has not been to the moon. But how do we know the materials you're building on Earth are actually going to work on the moon or on Mars or somewhere else?
Great question.
Yeah, great question.
I can start on that one. So how do we know? We do our best. We try. So we understand the conditions as best we can on the moon and Mars, and also in outer space, asteroids, etc., and take all the data that we have, understand as best we can, and then we simulate those kinds of conditions in labs here. We also do modeling so that we can also compare models to experimental, and so there is some risk involved, but we do our best for risk mitigation by doing a lot of testing. And then also early missions will do smaller types of demonstrations. Like we're looking to, on an Artemis 3 mission, go to the moon and do a small landing pad. So 2 feet by 2 feet or something like that, so that we can bring back all the learning from an actual example on the moon and then integrate that into our further development.
That's really interesting. Why wouldn't you try to use some of the materials on the moon to build things on the moon rather than try to build it here and hope for the best?
Well, we absolutely will use the materials on the moon and Mars, and we call that in situ resource utilization. So that's NASA speak for the stuff is there, let's use it instead of try to shoot it up from Earth, where it's extremely expensive to get outside. There's gravity and atmosphere. So we're going to use materials as we find them, but also to bring them back, bring enough of this stuff back from the moon is extremely expensive. So we have to figure out a good proxy, which we call simulants, and work from there and take it in stages until we're actually building on the moon.
Could I add to that? One way we know is another way we know rather is in the 60s and 70s, the Apollo missions brought back hundreds of pounds of lunar material. So we have a pretty good idea of what the real stuff looks like, what it behaves like to some extent, what it's made of, the chemistry of it. And there have been, not really publicized, but people we've sent, and other countries have sent probes there, actually brought material back from the moon. So there's a lot of work like that going on to make sure that we know what's there when we get there.
And when those materials came back to Earth, where are they? They're in a storage facility somewhere?
Yes, I don't know exactly where they are, but NASA has them, and it's quite difficult to get them, as Holly
I
can
think
tell
they're
you.
at JPL, Jet Propulsion Lab. I think they're out that way. Yeah.
And do only a certain number of people have access to that material?
Right. It's difficult to get half of a gram to do something with. And for our purposes, for my project, I need to heat the material, so that would be destructive as well. But there has been, one of my colleagues actually had his hands on several different Apollo mission samples and was able to do some work with them, analysis, including microwave heating, which is one of the things that I'm doing. And it was very interesting. So we've got a lot of data from his work and others who've studied these materials.
And you just mentioned a second ago heating. Why do you have to heat it? So that way we can make sure that it could survive under certain circumstances?
Correct. So we're looking at consolidating the dust. One is for landing pads, and another is for dust mitigation, just because the dust going everywhere can get into equipment, spacesuits when they were up there. So consolidating that. One of the ways to do that is to use heat in order to sinter or vitrify, to take those particles and kind of meld them together so they don't come apart again. And that's part of ceramic type processing, which we have a lot of expertise here at Alfred University.
That's interesting. And speaking of Alfred University, Roque, I think you study a number of things here. So what have you actually touched and worked with in terms of these simulations, or in terms of being a student?
Yeah, so through the Space Materials Institute and working with Holly, I've had the chance to kind of follow through on some of her ideas of microwave heating and heating these simulants. If we want to make construction materials, specifically the moon, that's what we've been working with. We have high vacuum chambers, and we're trying to simulate the environment of the moon using these high vacuum chambers, and we subject these simulants, which are as close as we can get to the surface of the moon, to microwaves and heat, and see how they react, see if we can consolidate them and create structures. And I've had the opportunity to work really up close and boots on the ground with all of that processing, and it's been really great for me.
And let's say there's a 15-year-old kid somewhere watching this segment, and they're thinking that this might be an interesting subject to study or field to get involved in. What would you say to them that they should be doing in high school to get ready for the position that you're in now?
Yeah, that's a good question. Definitely just learning just gaining a really broad knowledge of materials and applications for different materials. I think I didn't have any specific knowledge in space or space materials or even microwave materials interactions like I work with now. But having a general understanding of science and a foundation in physics and a foundation in materials understanding first, and then going and learning your specifics at your job is what you need. So I'd say to focus on understanding the really core fundamentals of math, science, and physics.
Matt, would you agree with that?
Very much, very much. I think that an engineer in general or a scientist in general, when they look at something, they're like, I wonder how that works. I think in a materials context, if you see something, a machine or some other process like that, the question would be, what's that made of? You know, what kind of material is that? You know, what properties does it have to have? You know, maybe not, obviously a 15-year-old isn't going to think like that, but it's that curiosity about how things work really that's necessary, I think, to go in this field, to be in this field.
And let's go down the road of the properties. So let's assume, are there ethical issues that you all have to deal with in terms of, let's say you alter the properties of some of these materials, could there be a danger in altering them too much?
For some materials, I think that's possible to do. You can make something that's not safe. There are a lot of materials that we get exposed to that are not safe. So that always has to be a consideration in what we do. You know, can the material be handled? Can it when it's in its final form? Is it going to be dangerous in some way? You know, such as a battery that might catch fire, for example. Those kind of things always have to be part of the equation.
We won't accidentally form a nuclear reactor or anything like that. But things like silica, there's silica sand, right? There's that's an ingredient in a lot of things that are in ceramic materials. And you can heat silica, and under certain conditions, it can form an SiO gas, which is very toxic. So you have to have an understanding of the materials you're working with, how to use them safely, wearing masks when you need to, having a hood. So all types of handling things, safety first, absolutely. We have to understand what could be the risk before we even touch anything, before we even make decisions about what kinds of materials we'll use. But in terms of altering things such that, you know, they turn into a fire-breathing dragon, or that's really not going to happen. We just have to be careful about handling. And
now, what kind of equipment do you have here? Is your lab sealed off? Can anyone just walk into it?
we lock the lab when we're not in there, but that's really because of, you know, there's students that might want to borrow something. But we don't use the clean room. We don't need it for what we are doing. There are some processes that you have to keep all dust out, keep it clean. We're clean. We keep control of it. I have a hood, a fume hood. So certain processes, it's usually dust more than any other types of fumes. We'll work in the fume hood so that we're not getting it all over ourselves. And then, wearing goggles when we need it, lab coats, gloves. We use gloves all the time to prevent both, powders on our hands or things, but also the oils from your hands to get into your process. You want to keep things so you know what you put in there and you did it intentionally.
And in terms of this dust, because I'm hearing that this dust is a real issue, so what other things do you do to prevent the dust from getting all over the place?
Well, if you're going to open a box and there's powder in it, right? You could, if you need to, tent it. You can have glove boxes. You could blow up glove boxes that you have this in there and put your hands in through gloves and things. We also have a very large glove box that has atmosphere control. But we do a pretty good job. We just handle it carefully, and we do clean up. When you have powder, you don't just sweep it or brush it. You take a wet or damp cloth and use that. These seem silly, but this is part of the training and working in a lab, in my lab here. So, yeah.
Well, this is really interesting. Can we get to the issue of kind of different paths that people can take, since you run this institute? So, what are some paths that your students are taking or have taken in terms of A, their research, but two, their careers, their career paths that they could have?
So, so really, coming to Space Materials Institute, they usually have an interest in these things, and so their career path should follow their interests, their passions. And it's not hard to find jobs associated with materials that are applicable in space, but also they can do other things. There's design, there's modeling, there's, even on the business side, engineering is a great foundation for all types of business-oriented careers. And then, we even have some of the ceramic artists that are involved with us. We have one intern of Space Materials Institute who's a dual major in ceramic art and ceramic engineering. And she's open to all sorts of ideas, but the engineering makes sense as well because you learn a lot of the technical things that even if you become an artist and you want to build large structures, and also the costing of things. I make sure they see that part of it, that they're understanding not only the cost of the materials and the space, but the cost of their own labor. And that's important for, when they go into industry, they go into jobs, they understand what is their value and how expensive are they. They want really good salaries, but okay, what does that mean in terms of what you're delivering and value?
When speaking of the costing of things, so is there a difference between this research or these jobs for NASA versus a private space enterprise? Maybe I'll throw that to you, Matt, since you're in.
I would say there is, especially right now, but I think in general, probably a publicly funded organization like NASA, it's not quite as lucrative as an industrial position. However, you might be trading that a little bit of salary for some extremely interesting and rewarding work where industry is about making money. And if you really want to do new things and really follow your curiosity and have opportunities to do some really interesting things, sometimes a place like NASA is a better place to go. So following the money isn't necessarily the right path. I can attest to that for everybody. But that's my feeling about it. I don't know a lot of data on that. So.
What about students, young students who are not from the United States? Can they work at NASA?
I think they can. If they are a naturalized citizen, I believe they need to be, or something along those lines, you can. So, yes, it's possible, sure.
And what about, I want to just go down this road a little bit. I realize we're having this discussion in New York State, but people overseas, let's say they're interested in these subjects. Yes, maybe they could come to Alfred University, but what if they can't physically get here? What paths would they have to study something like this if they lived in another country?
Well, there is a lot of this kind of work with space materials and space travel and all that going on in Europe, all over the world, really. It's pretty amazing how much money and effort is being committed to this, to getting to the moon, or excuse me, getting to space. European Space Agency is very much involved in working with NASA on the Artemis. You'll see their little logo right on the side of the rocket. There is some work going on in Australia that I've been exposed to a little bit. So there's work going on everywhere, and there's a lot of universities out there in Europe and overseas that are doing work in this area. So I think the opportunities are there for, and that's pretty much any area of of aerospace engineering and aerospace work.
And I want to drill down on that a little bit more, if we could, Roque, because you are the student here. So can you tell us a little bit more about some of the projects you're doing in classes? Because I think that might interest a number of people thinking about this. Like, wow, I didn't know that's specifically what I would study when I get to college XYZ.
Sure. Yeah, I didn't really even know when I first started in the material science route what I'd be doing. Okay, material science is so broad. Am I going to make new materials? Am I going to develop materials processes? And I've done a little bit of both. I know for Holly, we've been working on making landing pads for use on the moon. That's something I never would have expected I'd be a part of. And that's just one aspect, and that's kind of a ceramics base, but I've also had projects with improving energy efficient processes and improving the materials within fuel cells, solid state batteries. I've done a little bit of modeling, and you can go so many different directions. And what I do is I find professors or people around me that I like and I get along with well and that I can use as really great mentors, and I'll just jump in with their work and learn, see what I can learn and find my little niche within their work to focus on. And I've had a lot of success with that, and it's brought me to a really wide range of processes and development.
And where do you see yourself going after you graduate, if you don't mind me asking?
Yeah, it's changed a lot through my undergraduate study, definitely. I'm planning on going to grad school here first to learn more about ceramics. Holly and my work here has really hooked me on ceramics and pulled me from a broader materials down to there. And then from there on, I really enjoy working in electroceramics and energy efficient processing. That's what we do with our microwave processing, and that's what I've been working on with fuel cells and solid state batteries, and that's the area that I enjoy. And I'll try to stay in that field if I can, but first a little grad school.
Fair enough. And Holly, what other advice do you have for some students like Roque in terms of navigating their beginning of their careers in this?
So I like what Roque said, that look at things broadly, but also do a good job, work really hard on your science, your math, physics, study hard. But I'll tell you, there was a high school student from Westchester, New York, who reached out to me with her professors. They have a 3-year science project where they look for mentors doing something they're interested in. And she is now working with Space Materials Institute, looking at Martian habitats. And I'm very impressed. So anybody can reach out to me, to us, but also reach out and ask questions. People that are doing things that you're interested in, they actually can pay attention and say, yeah, we're looking for people in high school to come to university or to intern for jobs, intern at NASA, intern at companies that are doing interesting things. So I would recommend that they don't be shy, reach out, and pursue things that they find interesting, and they'll do very well.
Well, let's go down that road of that high school student that you just mentioned a second ago. So does a high school student have the ability to do, I assume not every high school student does, but do they really have the ability to contribute to your work?
Oh, absolutely. Roque, I've put Roque in charge of the student. And do you want to have a comment about that?
Yeah, I was blown away by how developed the student was just as a sophomore in high school. And because you can find so much online in terms of articles and just explanations, you could use AI even to help people really understand things faster and earlier than they normally would. And this student really has progressed her project without much help from us and just pulls on us when she needs things that she wouldn't be able to know yet because she hasn't got that education yet. But definitely students at any age really can contribute to really incredible projects like the ones we're doing.
Well, that's terrific. And Matt, do you have anything to say about this issue about some young people trying to get involved?
Yes, it's actually something I've been wanting. I try to do is whenever I can is to kind of spread the word about ceramics because not many people really understand what we do. But what I would say is that I didn't follow my passion when I went off to college. I didn't know exactly what I was going to do. I knew I wanted to go to college somewhere. I knew a couple other things, but I really didn't have a sharp, defined goal. Right? I wanted to be an engineer. I didn't know what kind. So I came here and got into ceramics. I thought, why not? Let's try it for a couple of years and see what happens. And I liked it. But it has developed into my passion. So over the years of doing, I've done a lot of different things. I've been able to travel the world through this work, get involved with everything from electronic ceramics to armor ceramics, just an amazing breadth of applications. And like I said, it has become my passion, and I think that's something to keep in mind as you're going out there looking for a path, as to, maybe it's not your passion yet, but if you have interest and you keep to it, it can be.
Well, that's good advice. Thank you all very much for taking the time to share this. And this is we've never done anything about space materials, and this is the first Space Materials Institute spotlight I've ever heard of or thought of. So thank you all very much.
Thank you.
Thanks for having me.
If you would like additional information about the Space Materials Institute here at Alfred University, please go to alfred.edu. If you have any comments or questions of me, please go ahead and send an email to highereducationtoday@topcolleges.com. And thank you for watching. We will continue to bring you quality discussions about important matters in today's college and university world. I'm Stephen Roy Goodman, and you've been watching Higher Education Today.